Hello again, class. I'm going to talk about how to test proportion. So if you have two different proportions, you want to see if they are similar or if they are different. This is how you would do it. And it's really useful when you're looking at changes in, say, demographics, changes in the population that are buying something, that are agreeing to something, reject rates, yields, etc. If there are some significant differences, and you can make you can make some predictions based upon that, and have some confidence in the data that's coming out of there. Okay, so there are three basic steps, as I try to do with some of the other calculations we do. Just try to put it in steps for you. So the three steps are: one, calculate the proportions of the two samples and the combined sample proportions. Okay, need those to translate the data. You need to compute what is called the standard error of the difference, because you're comparing two proportions here. Okay, if you recall, when doing confidence intervals for a proportion, we are looking at the standard error of the proportion. All right, it's similar. This is called standard error of the difference. And then what we do is we translate that difference into z units. Okay, so we can look at and go back into the table and use the z table as for comparison. All right. So what we need to do, because what we now are doing was we're actually doing a hypothesis testing for two proportions, and we're asking, are the two proportions equivalent? If you recall from class and from a different tutorial, what we're setting up is our null hypothesis. And the way we write that one here is that our HO is our null hypothesis, and what we're saying is that our proportions are equivalent. So we have P1 is equal to P2. That's our null hypothesis, that they are equivalent. Our alternative hypothesis, which is also called the research hypothesis, we write it as such. So H1, so we're saying in the alternate hypothesis that they are not equal. Okay, but we need to again, we're going to need to use the z table to compare this. So how confident do we want to be in that in our test, in our hypothesis? So what we're going to be using here is an alpha of 0.05. Okay. And this is what the equation looks like. Okay. We're going to be translating this into a z unit. So we have z equals, if you recall from doing a z, trying to do the z-score for variables, it looks very similar, right? So we have P1 minus P2 over the standard error of proportion. So in the other instance, when using it for variables, you would have an x minus the average over the standard deviation, correct? Okay, so it's quite simple. There's some steps to get there, though. All right. P1 and P2 are the different proportions, and those are easily calculated. Now this one here it looks kind of scary there, but it really isn't. Standard error of the difference in the proportions is the square root of the combined proportion times 1 minus the combined proportion times the number of samples for proportion 1, which is right here, the number of samples taken for proportion number 2, and that's going to be divided by n1 times n2. And to get P star here, which is the combined proportion, this is the equation for that. Okay. So for the example here, this is a real data from the FDA, And these are audit observations given to medical device companies, pharmaceutical companies, based upon the total number of inspections given that year, okay? So N1 here is the total number of inspections in 2008. That's 15,000. Total number of inspections for the year 2000. N2 is 18,000 here. And we have a difference in the number of audit observations. And these are kind of like, for those who aren't familiar with the industry, it's kind of like giving them a parking ticket, speeding ticket. Something wasn't correct and you need to fix them. All right. The individual proportions for each year are right here. So we need to calculate the proportions of the two samples. All right, we have that, P1 and P2, and then do the combined sample proportions. All right. That's 0.37. There are two ways to calculate. You can do it this way, or, because what you're doing is you're taking N1 times P1, adding that to N2 times P2, and dividing it by N1 plus N2. Or what you can simply do is add, in the numerator, add the total number of audit observations and divide it by the total number of inspections, and you'll come out to that. Okay. The next step is to calculate the standard error of the difference, okay? And that's this equation right here, all right? And we have all of the information. We have P1, P2, and P star here, okay? And then we input that information right here, okay? And what we get for the standard error of the difference is 0.002. All right, so for our third step, we translate that so we can look up this data in the Z table, all right? So now we go back to this familiar looking equation here for Z. So we have P1 right there minus P2 right there divided by standard error of the difference in proportions, 0.002, okay? So what it comes out to be is Z is equal to minus 40, which is a very large number. And if we go back to what our hypothesis was going to be, is we're saying that our null hypothesis was saying that these proportions are equivalent, okay? And we're using an alpha of 0.05. All right. Alpha value of 0.05 is 1.96, if we look that up in the table for two-tailed test. All right. And because our value is less than minus 1.96, we can say we're at least 95% confident that the proportions are not the same, okay? So we would reject the null hypothesis that P1 is equal to P2. As a matter of fact, we can actually say we have a greater than 99.9% confidence, as Z is much greater than minus 3.291, okay? So this is the 3 steps to compare two proportions and do some hypothesis testing with it. Okay? Thanks.